camera depth camera information over the ROS network. We want to know what's happening in there. So this package will allow us to do so. So let's actually very fast go through this tutorial. So the first thing that we need to do is we need to run the YAML file with the recipe. So let me go to my desktop and we will do the command for running the recipe. So hopefully I have it here. Yeah, let me actually use in this type copy. Oh. No. Test space copy. I should just give me a moment. I will change the name because this is not a good name for a file to have. Rename performance test 2. So let's actually go through the recipe very fast. We actually were showing this during the questions and answer. What we have is that we are creating a network, a Kubernetes network. It has already been configured, but you will need to configure it accordingly to your local system. So follow along the demonstration very up in the repo to configure this properly. And then
showcase sorry to interrupt you. We have showcased this during the step 2 that we will go back in a second.
Okay, perfect. So Bartosz will be going through this. So basically what we have here is 2 pods. We have 3 lines defining that this is a different thing. And what we are running is we are getting this image, which is a custom image created by us. We are getting it from AWS, and this is the image that contains Apex AI already installed with ROS 2.
This is the image that we have built in a first step, but for your convenience to access it, it is uploaded to the public AWS container repository.
Exactly. So let's just run this. Okay. Apparently my network was already created, so it says it is unchanged and has created these 2 packages. So very fast, we will have a look in here and see what we have. Let me actually clear. That's too much. Okay, so we have our talker and the listener. So what we are going to do is we will accept and connect to any of these pods by putting the ID of the container. I hope it is already soon enough to connect. Yeah. And let's source everything before doing anything. Those 2 foxes, bash, and we will run the experiment here. So first of all, actually, just for your convenience, I have already created a file I will share with everyone. These are all the data types that can be used within the Apex AI tool. So there is a good variety. So we will have some point cloud for camera, we have radar, we have range, we even have some more very simple data types. So yeah, these are all the data types to be used within the tool. So let's paste this and let me go here. It is not ready installed probably. OPT performance test, lib performance test. Okay. So we have here in green the name of the actual executable, and if we put perf test test and we do -h, it's not working. Maybe I need to source something. Okay, so let me actually do this. I have changed the command, removing this and writing -h. So -h is the hub parameter for the executable, and this will give you a lot of guidance for what kind of configurations you can run your test. So you can save your file into JSON format, into CSV, and then you can also display all the data types that the tool supports. You can also put some ROS domain ID if you are using the DDS discovery server, for example, and many other parameters like the type of DDS technology that you want, and so on and so forth. So let's actually run the full command. Here is the demonstration. And this will keep on running basically forever. So it is up to us to decide how long we want to be running this file. So the name of the file is going to be a result test topic. There is a date with the hours of our test with a CSV file. So let's do Control-C to stop it. And in the route where we have launched the file, we will have, in this case, I launched it 2 times, so that is why we have 2. These are the results. And then you can use Kubernetes copy to copy the actual file to your local system and visualize it more properly. So because this is a CSV file, we can put it in like nice columns, and then you can study the data more carefully. And I think that is going to be all from me. Here you have in all the official documentation in Google Drive of the Apex AI tool. And then there is the official GitLab page for the Apex AI tool. So a lot of reference for you guys to have. Yeah, it doesn't make any sense for me to show you this one now. So I will be moving on to my colleague Bartosz. He will continue the presentation. Please feel free to ask any questions in the chat. Thank you very much.
Okay, quickly answering the question made by Za, would it be possible to get a resource usage of the Edge cloud to support the robot? Yes, it will be possible, but not from the level of the single container. We'll have to take a look on the OpenStack and the AWS management panel if we will use the AWS cloud. But I'll show this later on. How can we take a look on the general usage of the resources? But in the case of automating this, this is a thing that we'll have to research a bit more. Okay, so let me quickly share my screen back. Okay, so we have fixed the issue that we had. It was really simple. Microcase was just not started, so sorry about that. So right now we'll start where we have finished. So we will be applying the configuration of the Multus config YAML, and now you can see I have already created it, and it works correctly. The network attachment definition has been created. In the other window, we can see I have used the watch-c microcase kubectl get all command to have a constant view on the status of the services that are running on the microchains. So I'll start it in here and let it work in the background. And in the meanwhile, in the other terminal, I'll showcase you what is actually needed to use this additional network card that Multus gives us in our pods and deployment. Adrian has already mentioned it during the break, but I'll explain it a bit more in detail. So let's edit the Vim. Let's start with the listener file. As you can see, this is the standard deployment definition for the For the Kubernetes, we have specified the API version, what kind of the file it is. We are specifying the deployment. We are naming it, adding some labels. And what is the most important thing in here to add the network card is the annotations in here. We are using the caints.v1cni.cnf.io/networks, which is, I believe, the same as we have specified the API version in the multus config file. We are specifying the name of the network attachment definition that we have created before. And also we'll have to repeat this step inside of the specification for the deployment. As you can see, we are specifying for now one replica, and for the template, we are using, once again, labels and annotations. So every single pod that will be deployed with, that will be created with this deployment, will have an access to additional network card. Even if we will scale up or down the number of replicas, each one of them will have this pod. Each one of those pods will have this network card assigned to it. For what I have changed in here, we are not using the image that we have built, but as I have mentioned before, we are using already uploaded version of the image to the public AWS registry. So you will be able to use it straight away without the need to compile it, export it, and then import it once again to the microK8s environment. Underneath it, we've got the standard command to start process in Kubernetes. We are sourcing the setup for us, and then we'll run the example Docker and the listener application. For now, we are starting just the listener part, and we'll pull the image if the image is not present for the efficiency purposes. So now let me exit it. I have not changed anything, so you can just exit it. This file is ready to be launched. To do this, we'll use once again command microK8s.kubectl apply-f. So we will applying the file, and then listener.yaml. Listener deployment created. So we got this information, and now we can see that we've got the listener deployed, and the pod is already running because I have downloaded this image before, so we will not be waiting those 2 minutes for it to be downloaded. So now in the other terminal window, I think that I can use this one. Let's clear it, and what we will do, we will try to follow what is happening inside of the this listener that we have deployed. To do so, we'll use microK8s.kubectl, and then we've got part logs -- follow to have a constant flow of the output from the container, and then we'll specify the applications by the label, which is app equals roles-listener. We have specified this label in the YAML file, so we will be able to easily access this application without using the pod's full name. As you can see, there's nothing right now. The listener is not receiving anything, so we'll move to the Docker. Let's use vim docker.yaml. And as you can see, we've got the same structure. We have changed only the labels, so we know that this is a ROS Docker. The annotations part are the same. So we know that there is an additional network card inside of the pods, and we are specifying the same image that we have